Given that paper 2 is a calculated paper, this question is very straightforward, and indeed all you really need to do here is just graph this function for this domain here, and then you can use graph trace here and here, find the zeros to find the x-intercept, and again read off the graph to find horizontal asymptote. Just as a walkthrough of how you can do it without using a calculator. If we think about an exponential function, so e to the ax, so whatever value a would take, you would have a graph that looks something like this going through the point here, 0, 1, and that is because whenever x is 0, we're going to have e to the power 0, and anything to the power 0 is 1. So the intercept would normally be at 0, 1. This effect here is a transformation of down 2 units, so that would move it down from 1 by 2 units to give you -1. So the y-intercept would be 0, -1. The x-intercept, again, very easy to do on the calculator, but if we didn't, we would know that if we've got fx equals e to the 0.5x minus 2, the x-intercept is where y is 0. So we would have 0 equals e to the 0.5x minus 2. We could then rearrange that as e to the 0.5x equals 2 and take the ln of both sides. So 0.5x equals ln 2, and therefore x equals 2 ln 2. And that's going to give you 1.39, which is the same value that you would have found if you had gone to analyze graph and find the zeros. Similarly, normally this asymptote here on the graph of e to the ax, the horizontal asymptote is line y equals 0. Because the graph has been translated down 2 units in part C or part 3 here, the equation of the horizontal asymptote would just be y equals -2. In part B then, the final thing, we are just asked to sketch it. So we've got the y-intercept is here, we have got the x-intercept is here, we've got the horizontal asymptote at here, y equals -2. So our graph should look something like this. And provided it goes roughly through those points, you will get the marks for that.